Okay, so let's see, I'll make sure that I can, uh-oh, how do okay. All right, so I'm going to talk about what we refer to as the variable cascade, which is the way to describe variables. This approach is in GSIM and in a couple of the DDI standards, so it's becoming a common way of describing variables. So first, what do we mean by a variable? It's a mapping between a set of units, we can call that a sample, and a value domain that I will describe in a second. So this idea is similar to a function in mathematics where the domain is the sample and the range is the value domain. So we talk about units, and these are the objects that we collect data on or about or from. They're the things that the data describe, and the set of them is called the sample. The value domain is the set of allowed values, the meanings and the representation that the variable takes. So, for instance, in a marital status variable, we might have the categories single, married, divorced, and widowed, and use the first letter of each of them as a code for representing them. So I have these ordered pairs there, S for single, M for married, and so on. We could also have a variable on age where we have a range in years. Let's say we say 100 is the oldest, and we could represent that in Arabic numerals. So this is a way to, this is a way to describe variables, and we'll get into more detail as we go. So the when we think about units, we can describe units in various levels of detail. So we have the fundamental idea of something called a unit type. It's the fundamental class of units for which an organization requires data. A sample is a subset of this set of the unit type. Some examples in the US at the US Bureau of Labor Statistics, the basic unit types are people, households, and business establishments. At the US Department of Labor, BLS is an agency, but outside of BLS, they talk about business establishments and inspections of businesses and enforcements and program recipients. At the U.S. Fish and Wildlife Service, they are interested in animals, fishes, mammals, birds, and so forth. So, for instance, we could think of people as a kind of mammal, right? But what turns out to be the unit types for one organization might not be a unit type in another. So the organizational context matters. If we go on, so getting a little bit more specialized, we have the idea of a universe. So it's is a specialization of unit type by subject matter characteristics. So women are people who are female and at least 18 years old. Mines are business establishments where minerals are extracted. Bears are animals that are omnivorous, mammals, and scavengers, and so on. So you can see that you take a unit type and specialize it to the kind of thing that you're that describes the units that you're collecting data about. And then the further specialization is to what we call a population, where we add the time and location. So for instance, women in the US in February 2025, US mines in Colorado, if you're not familiar with the US, that's one of the states, in 2020, or bears in Yellowstone Park. Yellowstone is one of the famous national parks in the US in 1960. So the the unit type universe population is like a path of specializing to get more specific, to talk about a general description of the set of units that we're collecting data about. And these are tied to the descriptions of the variables. We call this the unit cascade in DDI. So we also want to talk about value domains. These are the allowed values that a variable takes. So we talked about the marital status and age examples, but value domains come in two type systems based on usage and structure. For usage, we have the idea of a substantive versus sentinel value domain. Substantive value domains are values based on the subject matter. So, for instance, the marital status classification. And the sentinel values are those that are for processing. Say, why might data be missing? uh, where are data in the various levels of processing? They might be waiting for a calculation or so on. So the sentinel values are about processing. The substantive values are about subject matter. The other type system is about structure. So we can have an enumerated type, which is we list all the possibilities, say in the marital status example, or we can scribe them using a rule or a range. So in the age example, we had a range of for the numbers representing the ages. So more generally, a rule is based on text strings, say for qualitative data like names or uh, uh, so forth. You can also have rules for identifiers. A range is applied to usually for dates and times. Um, and we can also apply ranges for quantities. We can use integers for counts, real numbers for inexact quantities, or scale numbers, say, for currencies. Part of the description of a value domain is what's called the conceptual domain, which is the set of all the meanings associated with the values. So um, in the marital status example, we have the categories single, married, divorced, and widow. Those are of course, those are names, but the idea is to convey the meaning of the categories that are each represented in VD1, value domain 1, and VD2, value domain 2. We can see that each of these categories is represented in different ways. In value domain 1, the representation, the codes are single characters. In value domain 2, we're using numerals. So there are different ways of representing the same thing, and the conceptual domain is a way of tying these together. So, sorry. So this leads us then to the variable cascade, which is a means for describing the variables. We've described the fundamentals of what we need to bring to bear, but now we're going to show how this is organized in the levels. So there are four basic levels: the defining concept, what we call the conceptual variable, the represented variable, and the instance variable. Now, these levels aren't to be confused with variables themselves. They're just parts of the description, and each represents a more detailed view of what the variable means. Um, each level is meant to be reusable and separable, and therefore part of the way that you would describe all the variables across all the surveys and other collections um, that an organization has. So the concept level, it's used to define a variable. For instance, what do we mean by marital status? What do we mean by age? And these are characteristics of the unit classes. So people have a marital status. People have an age. Age could also be applied to other unit types too. So all marital status variables share the same concept. All age variables similarly share the same concept. So that's why it's at the highest level. And we can see that if we have a unit type people, we can divide that into these two characteristics, each defined by a concept, marital status and age. If we go to the next level, the conceptual variable, that includes the concept, but it also includes the conceptual domain that the variable will use. So we can have one conceptual domain, which is in for the marital status. We can have four categories. We could also represent marital status using two categories. But note if we have a category single in the two category set, it will not mean the same thing as the single in the four category set. Because in the two category set, single means not married. In the four category set, single means never married. So these two categorizations categorize marital status differently. And so in the context of these two different conceptual domains, we interpret the basic meaning, the concept meaning of marital status slightly differently. Going a little further, we can also look at age, where we have whole numbers greater than 0 and possibly up to 100. We don't know right now if the number represents years, but we do know that we're using whole numbers to represent the age. The number could also represent days that the person is alive, for instance. It doesn't have to be years. But numbers themselves are concepts. So when we talk about whole numbers, we're talking conceptual. And this is what we mean by a conceptual domain for a range. So the conceptual domains list the concepts underlying the data that the data represent. And showing again how we add this in, the marital status can be divided into the four category marital status or the two category marital status. For age, we just have one way of representing it using the whole numbers. Now, when we move to the represented variable, then we include the conceptual variable plus several things. So we include a unit of measure. We include what's called the intended data type. How do we expect this data to be used? This is not about how the data are stored. So if the marital status categories, let's say, are represented with numerals, that does not mean the data are numeric. It just means that we're taking numeric characters and representing the categories. So it's nominal data. That means an unordered set of categories. For in the case of ranges for counts, um, measures, scales, and times, we'll have some way of representing them using usually in some numeric frame. So if we continue then with the marital status categories, we see that we can represent the marital statuses in different ways. So using the four category marital status, we can use the S, M, D, and W representation, or the numerals 1, 2, 3, and 4. We can do the same with the two category set. For age, we're interested in whole numbers, and typically we represent that using Arabic numerals. And this will also include the bounds for the range. So we may have a top code as well as a bottom code. Looking at this graphically again, for the four category marital status, we can use the letter codes or we can use the numeral codes. For the two category, we just have the letter codes, and then for the age, we have the Arabic numerals. And this is what the representative variable is about. It's the conceptual variable plus the representation and some well, if unit of measure is necessary, we supply that, and we also tell you how to interpret what the representations mean. So if it's numeric, they may not be numbers, they might just be characters. At the instance variable level, then this is the lowest level. We include not only the represented variable, but also the sentinel values. And the sentinel value domain is the values representing the needs for processing, like missing and refused. It turns out that R, SAS, SPSS, and Stata all represent missing and refused in different ways. But an example might just be that you use M for missing, R for refused, and say P for processing error. That I don't think that corresponds to any one of those four, but it's a way it could be done. Again, in a far more complicated way, we see below the red line the possible instance variables for each of the represented variables just above the dotted red line. Each instance variable I have included a possible usage type. So we'd have a different instance variable each time we have a different way of representing the data in some way. So we could represent it in SAS, in R, in a CSV, say for Excel, or just a comma separated file, and so forth. So what we see here is the increasing detail in the way that we talk about the description of a variable. So that's it. I can take we'll have questions at the end. Thank you.